What is up, young chemists? Mr. Rosen here. Today we're going to talk about the concept of density. Density is an intrinsic property of matter, which means that it doesn't change depending on how much you have. If you have a lot of something or a small amount of something, either way, the density is going to stay the same. Although that could change depending on the conditions. If temperature changes, something's density might change. So, the equation or formula, I guess, for calculating density is here. Pretty easy, pretty straightforward. The density of a substance is its mass divided by its volume. Okay, so it's the ratio of an object's mass divided by its volume. The most commonly used units are grams per milliliter, and a milliliter is the same thing as a cubic centimeter. So grams per cubic centimeter or grams per milliliter, those are both typical units of density. So our early problems are going to give you both mass and volume, and you're going to calculate density. So in this first example, it says a piece of aluminum has a volume of 5.63 cubic centimeters and has a mass of 15.2 grams. What is the density of the aluminum? So density equals the mass. Now, if you're trying to figure out which of these is the mass, you have to look at the units and know that centimeters cubed is not a mass. That's a length by a length by a length. That's three-dimensional length is volume. Grams is unit of mass. So mass goes on top, 15.2 grams, and volume goes on bottom, 5.63 cubic centimeters. So if you take grams divided by cubic centimeters, your answer is going to be density in grams per cubic centimeter. Now let's see what our calculator spits out. And if you're watching the videos in order, you'll see that our recent video on significant figures will be useful here. 15.2 divided by 5.63, and that's what our calculator spits out. Okay, so I'm just going to write that down. 2.69982238 grams per cubic centimeter. Okay, so this says that we know the density all the way out to the almost the billionths place. We don't know that. Some of this we know with certainty, and some of this we don't know. Some of this is just kind of gibberish your calculator spits out. So where are we going to round? Are we going to get rid of just this last part here? Are we going to get rid of all of the decimal, the places after the decimal point? Well, we divided, which means that our answer can only have as many significant figures as the measurement with the least amount of significant figures. So this has 1, 2, 3 significant figures. This has 1, 2, 3 significant figures. So our answer can only have 3 significant figures. So to round this to 3 significant figures, we would have 2 point. Now, 3 sig figs could be 6, 9, but you wouldn't leave this at 9. You would actually go 2.70. And that is a trailing zero, which is significant because we have a decimal point, and that's grams per cubic centimeter. So that is rounding our answer to 3 significant figures. And moving forward, we're going to round all of our answers to correct significant figures, now that we've covered them. And if you haven't covered it, or you don't remember rounding to correct sig figs, please watch the video on significant figures. Okay? So there's an example problem here on the screen. If you want to pause the video, and there is a little bit of a calculation space here below. If you would like to pause the video and work these problems and then see how you do, you can do that now, but I'm about to solve them. So there are 2 sapphires, which is a gem, and the mass and volume of each is provided, and you're going to calculate the density. So density is mass divided by volume. So for number 1, you have 25 grams and 6.33 cubic centimeters. And then for number 2, you have 341 grams. Oof, that's a big gem. It's like 3/4 of a pound. And then you have it 86.3 cubic centimeters. So I'm going to plug these into the calculator and see what I get for each. 25 divided by 6.33. Okay, so I will write this down. 3.949447077 grams per cubic centimeter. Sorry if that's a little small. But again, we're going to round this. This has 3 significant figures. That's a trailing 0, and this is 3. So to round this to 3 significant figures would be 3.95 grams per cubic centimeter. So the density of the first sapphire, the smaller sapphire, is 3.95 grams per cubic centimeter. Let's check the second one here. Okay, so the second one is 341 grams divided by 86.3 grams. And if we write that down, 3.951332561, we'll round that again to 3 significant figures, and that's 3.95 grams per cubic centimeter. Now you might pause and wait. You might think, hold on a second. This and this have the same density. That's not by coincidence. That's not random chance. You might think, hold on. These 2 sapphires have totally different masses. This one has a mass of 341 grams. This is only 25 grams. How can they have the same density? Well, they also have different volumes, right? They have different masses and different volumes. But what this is showing you is the ratio between the mass and the volume stays the same. So this increases by some amount. This will increase by the same factor. And the density is the same. So this is what I was saying earlier. I guess these should be written here in the spaces provided. Sorry about that. But whether you have a little or whether you have a lot, okay, so whether it's a small sapphire or a big sapphire, either way, the density is going to be the same because it is sapphire, right? It's not a different material. And the same with aluminum, right? If you have a small, you have like a small, piece of aluminum, just like let's say it's a little piece of aluminum foil, or you have, a big piece of aluminum, I don't know, maybe a big aluminum nail or something like that. If they're both just aluminum, they're both going to have the same density, regardless of the size, the mass, the shape, doesn't matter. If it's aluminum, it's got this density at a given set of conditions. So down here you can see it says, here I'll just move this up. It says the accepted value for the density of sapphire is 3.95 grams per cubic centimeter. As you can see, the density will not change whether you have a lot of it or a small amount of it. So we call it an intrinsic property of matter. Now, so far we've just done example problems where you know the mass and you know the volume. Mass divided by volume is density. That's what we've been doing, these practice problems. But you could be given the density and asked to solve for something else. So solving for other variables, this is sort of a handy-dandy little triangle where here you can see density is equal to mass over volume, mass divided by volume. That's what we've been doing. But if you are solving for volume, that's mass divided by density. Or if you want to solve for mass, it's density times volume. So if you know 2 of the 3, you can solve for the other. And we're going to be doing some practice solving not just for density, but also for mass and volume. And if you pay attention to the units, you'll see that your units will cancel out if you do this to give you the unit that you desire. Okay, let's do some practice problems. Okay, now at any point, it's always a good idea to maybe pause and try to do some of these problems on your own. So here are some practice problems, 1 through 4. If you want to pause the video and just solve these, jot them down, your answers down on a piece of paper and see how you do. That's a good idea. And then I'm going to work them out. All right. So let's do these. Question number 1. It says a piece of metal has a volume of 20 milliliters. Okay, remember a milliliter is the same thing as a cubic centimeter, so we can leave it, it's fine. And a mass of 71 grams. What is its density? So just like we did in the previous problems, density is mass divided by volume. So that's 71 grams divided by 20 milliliters. So grams divided by milliliters. We have 71 divided by 20, 3.55. And that is, both of these have 3 significant figures, so 3.55, and that's grams per milliliter. That's the same as grams per cubic centimeter. And that's 3 significant figures. Next one. Calculate the density of a material that has a mass of this and a volume of this. Again, they're giving us mass and volume. So these are like as easy as it gets. So 62.457 grams divided by 13.5 cubic centimeters. Let's see what our calculator gives us and what kind of rounding we need to do. 62.457 divided by 13.5. Okay, so I'll jot this down. 4.626444. Well, a lot of 4s. Okay, it kind of keeps going there. This has 5 significant figures, and this has 3 significant figures, so our answer can only have 3 significant figures. So that's 4.6, and this is closer to 6.3 than it is to 6.2, so this goes to 6.3, and that's grams per cubic centimeter. So that's our answer, rounded to 3 significant figures. Now this one, it says, what is the mass of an 18 milliliter sample of mercury if the density is 13.55 grams per cubic centimeter? So they're giving you the density. So in terms of writing it, it would be writing it like this, right? 13.55 grams per cubic centimeter equals some mass, right, that's a question mark, some mass over 18, now milliliter is the same as cubic centimeter, so maybe in terms of canceling our units, it would just be easier to write it as centimeters cubed, because I want you to see the units canceling. But if we're solving for this, right, in this case we're solving for mass. Mass is simply density times volume. Density times volume is mass. So we're going to multiply these two. 13.55 times 18. Now, this gives us 243.9 on our calculator. Now, if you take grams divided by centimeters, multiplied by centimeters, that's centimeters cubed in both cases, sorry, the unit of centimeters cubed is going to cancel. and you'll be left with grams. This number has 3 significant figures, and this number has 4. So our answer can only have 3 sig figs. So we're going to go 244 grams. That is the mass. And if you want to check your work, you can always just take your grams and divide it by your volume and see if you end up with the density, right? Density is mass divided by volume. If you take 244 and you divide it by 18, you should get a number very, very, very close to 13.55 grams per cubic centimeter, which is your density, which means it's right. So you can kind of check your own work in this way. Okay. The next problem, it says a piece of pure gold has a density of 19.32 grams per cubic centimeter. How large would a piece of gold be if it had a mass of? Okay, so how large would it be? So they're asking about volume, and they're giving you density. So 19.32 grams per cubic centimeter equals 218.97 grams over some volume. And they're asking you, how big would it be? If you have this many grams of it, and we know the density, right, 19.32 grams per cubic centimeter. So if you're solving for volume, volume is simply mass divided by density. And hopefully this makes sense. If each cubic centimeter is 19.32 grams, if you take 200, how many grams you have, and you divide it by this number, you're going to end up with your number of centimeters, right? It's basically 19.32 goes into this how many times, and that will tell you the number of centimeters. And again, grams will cancel. So on our calculator here, we'll bring this in. I guess I have to cover it up a little bit. But you're going to take 218.97, that's your mass, and you're going to divide it by your density, which is 19.32. And your calculator gives you 11.3338509.3, blah, 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 blah. This has 4 sig figs, this has 5 sig figs, so we're going to go to 4 sig figs here. So that's 11.33. Our units of grams have canceled, and so that is cubic centimeters. That's your volume. And again, if you want to check your work, you can take this mass and divide it by this volume and see if you get 19.32. And you should get something very, very close to that. Maybe slightly different due to our rounding, but should be very, very close. Okay, now one other style of density problem that you might see besides these calculations is plotting density on a graph or answering questions based on a density graph. So here is an example of 3 different metals plotted on a graph. We have the mass on our y-axis and the volume on our x-axis. So mass divided by volume, that's density. And notice, if you plot the density for each substance, you get a linear slope, right? Straight line. And some of them have a steeper slope and some of them have a more shallow slope. Big idea, steeper slope means more dense, okay? So steeper slope, more dense. And the reason that makes sense is, if you were to look like right here, this is 10 milliliters. That means if you have a 10 milliliter sample of this, which is aluminum, it's a little bit over 25, maybe 26 or 27 grams. If you have 10 milliliters of titanium, it's closer to maybe like 45. If you had 10 milliliters of brass, it's like close to 80 grams. So these are all, along this line, these are all 10 milliliter samples. The brass weighs, maybe 80 grams, whereas the same volume of aluminum is only like 27, 26 grams. So greater density means more mass per unit volume. Larger number on top, smaller number on the bottom. And these all have the same number on the bottom. So the more dense one has a steeper slope. The less dense one has a more shallow slope. So that's a key idea. And notice that the density is the same. So if you take, the mass divided by the volume here, let's just say this is 80 divided by 10. If you doubled the volume, right, 20, this is, close to whatever, 160, I'm estimating, of course. But if you took 80 divided by 10 versus 60 divided by 20, you would get the same number because you have the same density. So number 1 says, which metal has the lowest density? The lowest density is going to be the lowest density is going to be the one with the most shallow slope, and this is going to be the most dense. So the lowest density has the circles, and the circles are aluminum. The highest density has the steepest slope, that has the squares, so that's brass. And now keep in mind, this is just the highest density of the 3 things on there. There are plenty of things more dense than brass. And then it says, here it says, the next question, what is the density of aluminum? So aluminum is the one with the circle. To find density, it's mass divided by volume. So you can take any point on this line to find the density. You could take any point and just take what the mass is divided by what the volume is. It's helpful to pick, a point that's close to some lines. Like this is 10, and this is just above the dotted line here. So let's say maybe 26, just because it's above 25, and this is right on 10. So if we did 26 grams divided by 10 milliliters, we would get about 2.6 grams per milliliter. The accepted value is 2.7. We actually calculated that on the previous page, but based on just eyeballing this, it's good enough. Now, number 4 is a challenge question, or a little bit more challenging of a question. It says, if the student found the volume of a brass sample to be 22.5 milliliters, what would be the mass of the sample? We need to try to solve that. Okay, if you need to pause, you can pause. Okay, so it says the volume is this. What would be the mass? Now, in order to solve for mass, you need to know the volume and the density. So we're actually going to find the density of brass and then use it to answer this problem. So brass is the steepest slope here. You can pick any point. This one, I was saying earlier, maybe it's around 80, or that's a little bit hard. But if you look at this point, it comes very close to intersecting 125 at 15, right? That's pretty close to both, right on both lines. So if we take 125 grams and we divide it by 15 milliliters, this is going to be our density, which it might be a little bit off because we're estimating, but it's very close to 3.3, 3.33 repeating. Okay, and this is grams per milliliter. So that's our density. If we know density equals mass over volume, so we could just use this equals some mass over 22.5 milliliters, which is our volume. So if it's 8.3 grams per milliliter and we have 22.5 milliliters, we're just going to multiply these two. Okay, so if you multiply them, you get 187.5 grams. this, I guess we're saying it's 2 sig figs, so 2 sig figs, so we'll round to, I mean, how you did the measurement on this, we don't really know the precision, but we will just round it to 2 sig figs because I wrote 2 sig figs here and 2 sig figs here. So if we multiply this and you get 2 sig figs, that would have to be 190 with no decimal point. So that's 2 significant figures. It's a little bit of a round, but that's the process. You find the density using the chart, taking some point along that line, mass divided by volume, and then you solve for mass by multiplying density by volume. Okay, so in today's lesson, we practiced density calculations, solving for all 3 variables. We also looked at density graphs. Okay, remember the handy dandy density triangle here is helpful, and just like with our other stuff, practice makes perfect. So keep it up. Work, work, work. This is Mr. Rosen. I am out.